Next, now next type of question, that is short answer question type second, which carry 3 marks. These questions are asked in section 3. Now in which first question, what is the action of following on phenol at low temperature? Now first reagent is dilute HNO3, second reagent is concentrated H2SO4, and third is Br2 in CS2. Now each reaction carry 1 marks. Now first we are going to see dilute HNO3. Now here, when phenol react with dilute HNO3, that is nitric acid, at low temperature, it gives mixture of orthonitrophenol and paranitrophenol. Now look here, this is phenol, and when this phenol is treated with dilute HNO3 at low temperature, then hydrogen atom from ortho position of phenol is replaced by NO2 group to form orthonitrophenol, and hydrogen atom from para position of phenol is replaced by NO2 group to give paranitrophenol. Major product is orthonitrophenol. Then second, concentrated H2SO4, when it is treated with phenol at room temperature, then here sulfonation of phenol is carried out and formation of orthophenol sulfonic acid takes place. This is the reaction. When phenol is treated with concentrated H2SO4, then hydrogen atom from ortho position of phenol is replaced by SO3H group. Removal of H2O takes place to form orthophenol sulfonic acid. Now if this reaction is carried out at higher temperature, that is at 372 Kelvin temperature, then we'll get para product, that is paraphenol sulfonic acid. But at low temperature we'll get orthophenol sulfonic acid. Then last reaction, Br2 in CS2. Now this is bromination of phenol. When phenol react with Br2 in presence of carbon disulfide at low temperature, then hydrogen atom from para position of phenol is replaced by bromine to form orthobromophenol, and then hydrogen atom from para position of phenol is replaced by bromine to give parabromophenol. Now here parabromophenol obtained as a major product, while orthobromophenol is a minor product. Now second question, an unknown alcohol is treated with Lucas reagent. Explain how you will be determine whether the alcohol is primary, secondary or tertiary. Indicate this using chemical equation and the reaction between isopropyl alcohol and Lucas reagent. Now here Lucas reagent is nothing but mixture of concentrated HCl and anhydrous zinc chloride. Now when alcohol react with Lucas reagent gives alkyl chloride. Lucas reagent is nothing but concentrated HCl and anhydrous ZnCl2. Now reaction is when ROH, that is alcohol, when it is treated with Lucas reagent, that is concentrated HCl and ZnCl2, then hydroxy group from alcohol is replaced by Cl to give RCl. That is here when alcohol react with Lucas reagent gives alkyl chloride. Now here, now then second question, explain how you will determine whether the alcohol is primary, secondary or tertiary. Now here you have to give the reaction between alcohol and Lucas reagent, and you have to identify whether this alcohol is primary, secondary or tertiary. Now for this the tests are given, then observation, and from this you can carry out the inference. Now first test is unknown alcohol when it is treated with Lucas reagent, then observation is that reagent turns turbid on heating. That is, this reaction, that is unknown alcohol plus Lucas reagent, this reaction is slow reaction and which carry out after heating to form a product. That is, reagent turns turbid on heating. From this you can say that this alcohol is primary alcohol. That is, here rate of reaction of primary alcohol is low with Lucas reagent. Now second test, when unknown alcohol is treated with Lucas reagent, then reagent turns turbid slowly without heating. That is, slowly the reaction is carried out, but it does not require any heating. Then here you can say that this alcohol is secondary alcohol. And if this unknown alcohol is treated with Lucas reagent, then reagent turns turbid immediately without heating. From this you can say that this alcohol is tertiary. That is, here rate of tertiary alcohol, rate of reaction of tertiary alcohol is higher than that of secondary alcohol, and the rate of reaction of secondary alcohol is higher than that of primary alcohol. Then next question is, indicate the chemical equation, the reaction between isopropyl alcohol and Lucas reagent. Now the reaction between isopropyl alcohol and Lucas reagent. Now the reaction between isopropyl alcohol and Lucas reagent can be given as, now this is isopropyl alcohol, that is CH3CHOH CH3. When it is treated with HCl in presence of ZnCl2, then here hydroxy group from isopropyl alcohol is replaced by chlorine to give isopropyl chloride, that is CH3CHCl CH3. Now here the reagent will turn turbid slowly without heating. That is, this is secondary alcohol and therefore it is a slow reaction, but without heating this reagent turns turbid, but it is slow reaction. Next question, how will you bring about the following conversation? First is isopropyl alcohol to acetone, then second 2-methyl propane 2-OL to 2-methyl propene, and third is acetone to 2-methyl propane 2-OL. Now first we are going to see isopropyl alcohol to acetone. Now here when isopropyl alcohol undergo oxidation, then here formation of acetone takes place. Here oxidizing agent is used is copper, that is preheated copper at 573 Kelvin. Oxidation is carried out, and here this CHOH group is converted into C double bond O group, that is CH3 CHOH CH3, that is isopropyl alcohol. When it is heated with copper at 573 Kelvin temperature, oxidation is carried out and CHOH group of alcohol is converted into CO group, that is formation of CH3CO CH3 takes place. This is acetone. Then second 2-methyl isopropane 2-OL into 2-methyl propene. Now here 2-methyl propane 2-OL is a secondary alcohol, Now second, 2-methyl propane 2-OL into 2-methyl propene. Now here 2-methyl propane 2-OL is a tertiary alcohol, and here when this tertiary alcohol, that is 2-methyl propane 2-OL, when it is heated with copper at 573 Kelvin, then it undergo dehydration, that is removal of H2O, that is alpha beta elimination is carried out. It undergo dehydration to give CH3, C double bond CH2 and CH3, that is isobutylene, that is 2-methyl propene. This is isobutylene or 2-methyl propene. Then third reaction is conversion of acetone into to 2-methyl propane 2-OL. Now here when acetone is treated with Grignard's reagent in presence of dry ether. Now Grignard's reagent is methyl magnesium bromide. This is acetone, that is CH3COCH3 in presence of dry ether. Then here first formation of Mg complex takes place, that is CH3C, CH3, CH3, OMgBr. Then that is here addition of this CH3MgBr takes place across the double bond of this carbonyl group. This CH3 group get attached to this carbonyl carbon and MgBr get attached to this oxygen atom of carbonyl group to form this magnesium complex. And this magnesium complex, when undergo acid hydrolysis, there is formation of tertiary butyl alcohol or 2-methyl propane 2-OL takes place. This is tertiary alcohol plus MgBrOH. In this way, acetone is converted into 2-methyl propane 2-OL. Now next question. Compound A with molecular formula C6H5Cl is fused with NaOH at high temperature under pressure to give compound B. Compound B on treatment with dilute HCl gives compound C having characteristic carbolic odor. Write the chemical equation in support of this, name the process and give uses of compound C. Now here first we are going to see what is A. Compound A with molecular formula C6H5Cl. That is, it is a chlorobenzene. That is, compound A is nothing but chlorobenzene. Now here this chlorobenzene is fused with NaOH at high temperature under pressure to give compound B. Now this is chlorobenzene, and when this chlorobenzene is fused with NaOH at high temperature, that is at 623 Kelvin temperature under 300 atmospheric pressure, under 150 atmospheric pressure, then here HCl is removed and this chlorine is substituted by ONA group to form sodium phenoxide, and this sodium phenoxide when treated with dilute HCl, then here formation of phenol takes place. That is, compound B is sodium phenoxide and compound C is phenol. Now phenol is also named as carbolic acid and which have carbolic odor. This process is nothing but Dawes process. This process is nothing but Dawes process. The process involved is Dawes process. Now here name the process and give uses of compound C. Now this process is Dawes process and uses of phenol are: phenol is used to prepare phenol formaldehyde polymer like bakelite. That is, this phenol is used to prepare bakelite. Then next, phenol is used in antiseptic, in air freshener, in deodorants, mouthwash, floor cleaner, etc. That is, this phenol is used as antiseptic as well as disinfectant. Now next question. Write the preparation of ethanol from methyl magnesium iodide. Write the reaction between ethanol and acetic anhydride. Now here, first we are going to see preparation of ethanol from methyl magnesium iodide. Now here ethanol is prepared by using methyl magnesium iodide. Now when this methyl magnesium iodide is treated with formaldehyde, that is methanol, this is methanol or formaldehyde, and when it is treated with methyl magnesium iodide in presence of dry ether, then here this magnesium complex is obtained. That is, here this addition of this CH3 of Grignard's reagent, that is methyl magnesium iodide, takes place across the carbonyl carbon. Addition of this Grignard's reagent, that is CH3Mgi, takes place across the double bond of this carbonyl group of formaldehyde, and this CH3 get attached to this carbonyl carbon and Mgi get attached to this oxygen atom to form this addition product, that is magnesium complex. And this magnesium complex on hydrolysis, acid hydrolysis, gives ethanol, that is CH3CH2OH plus MgOHI. This is ethanol. In this way, formation of ethanol takes place from Grignard's reagent, that is methyl magnesium iodide. Then next, write the reaction between ethanol and acetic anhydride. Now ethanol react with acetic anhydride in acidic medium and gives corresponding ester. This is esterification process. Now this is ethanol and this is acetic anhydride. Now here this hydrogen atom from ethanol is replaced by COCH3 group to form CH3COO C2H5 plus CH3COOH, that is acetic acid is obtained as a byproduct, that is ethanoic acid. In this way, when ethanol react with acetic anhydride, gives ethyl acetate plus acetic acid. Next question. Write the reaction for preparation of carbolic acid from aniline. What is the action of concentrated H2SO4 on carbolic acid at 373 Kelvin? Now here carbolic acid is nothing but phenol. Now it is preparation of phenol from aniline. Now here when aniline react with nitrous acid, now nitrous acid is obtained at the time of reaction between sodium nitrite and concentrated HCl at low temperature. This reaction is carried out at lower temperature, that is 0 degrees Celsius to 5 degrees Celsius temperature. Then here formation of benzene diazonium chloride takes place, which on hydrolysis or which on acid hydrolysis gives carbolic acid, that is phenol. Now this is aniline. Aniline is nothing but C6H5NH2, that is NH2, that is amine group is directly attached to benzene ring. This is aniline, and when this aniline is treated with sodium nitrite and HCl at 273 to 278 Kelvin temperature, that is 0 degrees Celsius to 5 degrees Celsius temperature, then here formation of nitrous acid takes place, that is HNO2. And when reaction between this aniline and nitrous acid is carried out, then here formation of benzene diazonium chloride takes place. Now here this is benzene ring which is attached to N2Cl. This nitrogen atom possesses positive charge and here Cl minus possesses negative charge. This is a salt, benzene diazonium chloride. That is formation of this salt takes place. And this benzene diazonium chloride, when undergo acid hydrolysis, here formation of phenol takes place with evolution of nitrogen gas. This is phenol or carbolic acid. Now second question, what is the action of concentrated H2SO4 on carbolic acid at 373 Kelvin? Now here we have seen that when phenol is treated with concentrated sulfuric acid at lower temperature, then we'll get orthophenol sulfonic acid. And when phenol is treated with concentrated H2SO4 at 373 Kelvin, then we'll get paraphenol sulfonic acid. That is, at higher temperature we'll get paraphenol sulfonic acid. This is the reaction. This is the reaction. That is action of concentrated H2SO4 on carbolic acid at 373 Kelvin, formation of paraphenol sulfonic acid.